Hi everyone, good evening all. How are you guys? I hope I'm clearly audible to everyone. Okay, so guys, is my screen visible? What about others? Can you see my screen? No, yes, okay. Let me reshare it. Can you see it now? Okay, yeah, so in the last class, we had started with object-oriented programming, right? We have already discussed about what are classes, what are objects. We also learned about constructor and how we can create class and objects. Today we will discuss about the four pillars of OOPS. which are encapsulation, abstraction, inheritance, and polymorphism. Okay, so guys, just a minute. Yeah, okay. I'm sorry for that. Okay. So today we will be starting with encapsulation, abstraction, inheritance, and polymorphism. Okay. So let's start. What is encapsulation? As you can see over here, encapsulation is nothing but binding attributes and methods together, okay, or properties and behavior together inside one single unit. That is what encapsulation is. So we have already seen this concept actually. So binding the methods and attributes together inside a single unit. What we do basically, we create a class. In class, what we are doing, we are putting all the attributes along with the methods inside that particular unit. Okay, that's what we do in encapsulation. Okay, just there is one more added thing, and it should be that we should put restriction on accessing those variables and methods. Okay, so that no one can accidentally modify our variables value. So that's what we do in encapsulation. If we take an example of a company, okay, in a company we will be having different departments. Let's say HR department, uh, then technical department will be there, finance department will be there, sales department. Okay. Now, for some reason, if a person from, let's say, HR department needs some information from the finance department, okay, now that person cannot directly go and cannot access any of the data from the finance department. Okay, what he or she will have to do, first of all, that person will contact one person from the finance department that I need this particular data, and then a person from finance department will give that data to the another person, okay, which who is from HR department. Okay, so that's what we are doing in encapsulation. We are putting the restrictions on accessing our variables. So let's see it practically. I hope till now everything is clear. Guys, is it clear? Okay. So first of all, we will create one class. Let's say class is bank. Now this particular bank will have few attributes, like let's say account number. Okay. So first of all, I will create a constructor. Okay. It will take the mandatory parameter self. Then let's say account number and the account holder's name. Okay. As we know, we use constructor to initialize the variables. So we will do it. Account number is equal to account number, and self dot account holder's name will be. Okay. And now let's just define one method which will just display these particular information. That's it. Okay. So I'm just saying print self dot account number, comma self dot account holder's name. Okay, that's it. Now for now, what we have done so far, we took all the attributes and the methods and we are putting it inside one unit. Okay, half part of the encapsulation is done. Okay, let's create object of this class. It's a 1234 is the count number and holder's name is Leo. Okay, now what is happening over here? If I do something like this, b1 dot account number equal to 3421. If I do this and if I call that display method b1 dot display, you can see the account number was modified. Okay, see guys, account number is very sensitive information. Okay, and we should not allow this to be modified, okay, outside our class. And that's what encapsulation says. We should put restriction on accessing our data. Okay, so what we do basically, we take help of private variables or we can take help of protected variables. Okay, we will discuss the difference of what is private and protected once we see inheritance concept. For now, we'll just make our variables private. Okay, in Python, how we make a private variable is we just put double underscore in front of the variable name. So, okay, let's make both the variables as private. Okay. Here also we'll do this. Okay. So in Python, making private variable is nothing but just use a double underscore before your variable name. Now this time if you run this, you will see what happened. Mm. Okay guys, so this time if you can see over here, the account number was not updated. Okay, actually it should also give you an error. I'm not sure why it is not showing that error. Basically you won't be able to access this variable anymore, okay, once you make it private. Okay, let's try to print this instead. Print b1 dot count number. Yes. Okay, so guys, basically I'm not able to access this variable anymore. Okay, I will have to check why this is not showing you the error. It should show you the error called attribute error. Okay, because you won't be able to access, you won't be able to modify the private members outside that class. For now, is there any question? Okay, let me try once this on the other compiler. Let's see. It shows the error over there. Oops. Okay, let me just change this. Mm, okay, yeah. So see, this is the error I was talking about. Attribute error. Object does not have attribute a number. Okay. So you won't be able to access it now. Even if you try to update it, you will still see no modification in that particular variable. So guys, uh, if it's clear, please create a class and make your variables private. So in order to summarize this, encapsulation is nothing but binding your attributes and methods together inside one class and put restriction on the data. Okay, so that no one can access your data outside of that class. Okay, now to achieve this, what we do, we first of all we use class concept in order to bind the things together, and next to put the restrictions we make our variables private. So guys, please do it quickly. If you have any question, put it in the chat box. Okay. Shall I move on to next point? Okay. So I am moving on to next point. Next is abstraction. Okay. What is an abstraction? In abstraction, what we do is basically we hide unnecessary information from the user or irrelevant data from the user. Okay. And we just show what is necessary. So just like okay, let's take an example. You guys might be using Instagram. Okay. So when we you watch some reel, okay, you like it, you want that reel to be shared with your friend. You basically just click on that particular share icon, right? So basically you know what that particular button is doing, but you don't know how it is doing it. Okay. So basically you know what a function will do, but you don't know the processing behind that function. Okay, what is going on? That's what abstraction is. Now how we implement abstraction in Python is, let's see it programmatically. Guys, is my compiler visible? Guys, is my compiler visible? Okay. So first of all, there is a class in Python, okay, which we call it as abstract base class. So whenever you want to implement abstraction, you will have to import that class. That class is present in ABC module. So you will say from ABC import abstract base class, capital ABC. Okay, abstract base class. We will import one more thing, abstract method. Okay. We will be using this as a decorator. Okay. I will discuss what is an abstract method and what is an abstract class. So let's create a class called, um, let's see, shape. Okay. In bracket, I'm writing ABC. Okay. You will understand this once I discuss inheritance. Okay. Basically, this shape is a derived class, you can say, or a child class of this abstract base class. Now, what is an abstract class? An abstract class is a class which has one or more abstract methods, okay, or which can have one or more abstract method. Then what is abstract method? Abstract method is a method without implementation. Okay. Basically, you will be just creating a skeleton of a class, okay, a skeleton of a particular thing. And whenever you need it, you will just apply some styling to it. Okay. You can just take it as an example. We are just creating a skeleton. So in order to indicate that it's an abstract method, we will just use this decorator @abstract method. Okay. And let's define one method called area. Self. Okay. Now we don't have to provide any implementation to the method. So you will simply use this pass keyword. Okay. This is what an abstract method is, a method without implementation, and any class which includes one or more abstract method is an abstract class. Okay. Any question till now? Yes, it's like a template for creating something. You can consider. Any other question? Guys, no? Okay. So at the rate actually we use when it's like a decorator, Ganesh. At the rate abstract method, like we are just indicating that the thing we are writing below is a abstract method. It has no use, like it is not doing actually anything. Okay. So guys, please implement this much. After that, we will see where to implement this method. Okay. Once you are done, just put D in the chat box. Okay. So I'm moving on to next point. So before we see where to implement that method, we should first understand what is inheritance. Okay. So let's see. What is inheritance? Inheritance basically allow you to define a class that can inherit all the properties of some other class. The best example of inheritance is you and your parents. Okay. So you can consider parent as your base class. Okay. And you are the child. Now, there can be many attributes, many behavior which you have inherited from your parents, right? For example, anger issues or calm nature, okay? So there are many things which are inheritance, so basically which you are accessing from your parents itself, okay? And that's what concept of inheritance is. There will be a parent class, a child class, and a child can access all the properties, basically attributes and methods that are present in the parent class. Okay. Now there are different names. For parent class, you can also call it as base class or super class. Child class, you can also call it as derived class or subclass. So let's see how to, oh, okay. Let's see how to implement inheritance. Okay. for now I'm taking a different example, and then I will go back to this particular example. Okay, consider I'm creating a class called person or a human. Okay, this has one constructor, self, and let's attributes are name and age. Let's initialize these values. Okay, and one method will define, let's say, display method. This method will only return okay, my name is name. Self dot name. Okay, now this is one class I have created. I will consider this as a parent class. Okay, person. Now from this I can derive one class. Let's say that class is student. Okay. Now how to indicate that this is a child of this person class? We take the round brackets, and in the round brackets we will mention name of the parent class. So in our case it is person. Okay. Now see, one more thing guys in inheritance is, if you take an example, a real life example of you and your parent, there are many attributes which you have inherited from your parent. Along with that, you also have your own set of attributes. This can happen in, okay, yeah, in programming as well. So let's say this will also have its own constructor. Okay, self. Okay, self. It will have name. Student will also have name and age. Along with that, student will also have an extra attribute called roll number. Okay. Now we know that these attributes we have already initialized. Okay. We are also inheriting this particular class, which is person. Okay. Now we know that a child class can access all the attributes which are not private. Okay, which are not private from the parent class. So it means you can also access constructor of the parent class. Okay, now there are two ways of accessing this constructor. So let's take the first one, which is super method. Okay, you will write super dot init. Okay, and pass the parameters name comma age. This is how you can call a parent class constructor. And let's initialize these roll number. So you can say self dot roll number is equal to roll number. Okay. For now, I'm not creating any other thing inside the student class. Okay. Now we create the object of student class. So let's create the object. We'll pass all the values. Roll number is, let's say, 5. Okay. What I mentioned, you can access all the things from parent class. So even you can access this method. Okay, you can see I've not defined this method in the student class, still I can access it. So if you say s1 dot display, yeah, I'll have to print this because I'm not printing it. Okay, so see, my name is Leo. I should remove this. Okay, So that's what inheritance is. A child class is there which is able to inherit all the properties which are not private from its parent class. Is there any question for now? Guys, is there any question? No? Okay, great then. Now I will explain you the concept of protected variable. Okay. I have already mentioned that if you make your data members private, you won't be able to access the private attributes in your derived class. Okay. Private attributes will be accessible only inside that particular class. But if your attributes are protected, okay, protected means you will use only one underscore before your variable name. It makes it protected. Protected members are not accessible outside the class, but they are accessible in the derived or the child class. Okay, it means child class can access this protected member. Clear? Is it clear, guys? Guys, is it clear? Okay. After this, I will move on to our first example, the abstraction one, okay, where to implement this method. So guys, this particular, the abstract method needs to be implemented in the derived classes, in the child classes, okay? If you're creating the child of this shape class, you will have to give implementation of this method in the child class, okay? We will see this example uh, with one more concept, okay? But till then, there is a task for you on inheritance. So your task is you have to create a class called animal. Yeah, okay, animal, and create two child classes. One will be tiger, other will be lion. Attributes you can take on your own. Let's say in the parent class, attributes can be name and age, and in child class you can describe any attribute you want. Just make sure you have to implement the concept of inheritance. Once you are done, just put D in the chat box. Okay, I'm moving on to next point. Now, next is polymorphism. Okay, and this is the last pillar of object oriented programming. What is polymorphism? Polymorphism means one name having many forms. Okay, again, real life example of this can be you as a person. So, for example, you are a single entity. Okay, you are a single person who will be behaving differently at different places. Okay, for example, at home you will behave as a child of your parent. When you are with your friends, you will behave as a friend. When in school, college, or classes, you are a student. Okay, you are playing a role of a student. So you're a one person, one entity which is behaving differently at different places. That's what polymorphism is, one name having many forms. Now we have two different kinds of polymorphism. Okay, we have something called overloading and overriding. Okay, we'll first see what is method overloading is. So for that, let's go to compiler. Okay, method overloading means give me a second, I don't need this. There is a function which we have seen, a length function, len function. Okay, now see, when you can use that len function in order to find the length of a tuple, length of the list, or even a length of a string. Okay, for example, if you are having a string, you can calculate length of this using len function. Now you can use this same function to even calculate length of a list. So let's say you can say len and list, some list you can pass. In both the cases, you will get the result. Okay. So one function, one method is there which is behaving differently at different places. Okay. Let's take one more example. Example is addition function. Okay. Let's say you have a function called add, which is taking two parameters, num1, num2, and there is a third parameter which is a default. Okay, like this. And okay, for now I'm just printing this num1 plus num2 plus num3. Now you can do like multiple things, right? So you can use this function in order to find sum of two numbers, let's say 10 comma 15. You can even use this function in order to find sum of three numbers. Okay, addition of three numbers, and still it will work. This is what method overloading is. So basically you're having same name, like same function is there, but it is behaving differently. Is it clear? Function name but different number of arguments. That is overloading. Okay, so guys, shall I move on to next point? Four arguments, Ganesh, then you should have four parameters in the function. Then you can use that function even for the four numbers. Is it clear? Now we'll move on to the next point, which is method overriding. Okay, let's see what is method overriding. This is another form of polymorphism. Actually, another type of polymorphism. Okay. Now, for method overriding, we'll go back to the concept of classes inheritance. Okay. So for now, I don't need this. Okay. Over here, I have a base class person and a child class student. Okay. What is method overriding? Same name. Okay, everything is same, but that method is behaving differently at both the places. So, for example, in my student class as well, I will have one display method, same name, same number of parameters. Okay, but over here, this particular method will behave differently. So let's say over here it will print that display. So person dot display. Okay. Along with that, it will also print, let's say, str of self dot roll number. Oh, what happened now? Okay. So we are having same method, which is taking same number of parameters. Okay. But the implementation is different at different places. This is what method overriding is. Now this time the child class method will be called. Okay, so you can see my name is Leo along with 5 is also gets printed. Now going back to this example, okay, let's say this is having a class called square. Okay. The child class, it is a child class of shape. Okay, this will have constructor and everything. Okay, and square also has area, correct? So we will override this method in the child class. That's what we do. Okay, we always override our abstract methods in the child class. So basically we are providing implementation for that abstract method in the child class. Is it clear, guys? I will not show you because I have already explained you what is method overriding is. So if you don't have any question, your task is you have to create an abstract class, okay, which will have one abstract method called area, and you should override that method in the child class. So create a child class called square and provide implementation for the area method. This is your task. Once you are done, just put D in the chat box. Okay, guys, so that was it from my side for today's class. Do you have any question in any of the four topics? I hope everyone is done with the last task.